So in this section, we will explaining what framing is, and the objectives are: first, understand the framing; second, understand the framing errors. Suppose, let's assume, we have two nodes. This can be a computer or a router or a switch. The adapter will only be sending the data. So bit flows between adapters, frames between hosts. What does this mean? Bits flow between adapters, frames between hosts. It means that adapters send bits to each other, but these bits cannot be transferred up to the upper layers or to the bottom layers until you have enough number of bits that can form a frame. Once you have this frame complete, then you can transfer it up or down. Protocol defines the rules and regulations that govern data communication. So let the start of frame and end of frame be 110111. So this, whenever you see this code, it means that the frame starts. Whenever you see this code again, it means the frame stops here. The data in between is the raw data, which is related to the messages that you are sending or receiving. Let's assume there is an error here. Now, when an error can happen here, if within the data part you have a code that has the same values, just like the beginning or end of the frame, then an error will happen here. Why? Because then the receiver will think that this is the start of the packet, because it's the same as the code used for the starting. That's why we have a process called bit stuffing to solve this problem. Bit stuffing means if the raw data has a sequence which is similar to the beginning or end of the frame, then you change one of its bits so that it becomes different, and you inform the receiver about this. Let the start of a frame and end of the frame be 11011, data equals start of frame or end of frame. Here, as you can see, this data payload over here, if you can see the mouse here, is just like the start of the frame and end of the frame. This makes the communication ununderstandable, and therefore you need to find a way to solve it. Misunderstanding of communication, framing error, it drops the packet. So framing part 2, here the objective is to understand the basic framing, understand the types of framing, know various framing approaches. So framing in the data link layer separates a frame distinguishably from another frame. Frame equal header plus network layer, packet data unit plus trailer. Header include the physical address of source and destination. Trailer contains cyclic redundancy check bits that you can use to detect if there are errors in the frame or not. In packet switch network, the block of data called the frames are exchanged between nodes, not bit streams. This is node A, node B, adapter 1, adapter 2. So adapter 1 and adapter 2, bits flow between them, but frames flow between hosts. Once you have a full frame of, let's say, 15 kilobyte of bits, then you transfer it up. As long as you are not reaching this limit, it's stored in a buffer. When node A wishes to transmit a frame to node B, it tells its adapter to transmit a frame from the node's memory, This results in a sequence of bits being sent over the link. The adapter in node B then collects together the sequence of bits arriving on the link and deposits the corresponding frame in B's memory. So these are the details.